Nepal, Bangladesh, and India are one of the most diverse regions of the world in terms of language, culture, religion, and geography, with a shared Himalayan ecosystem. The floodplain riverscape of Koshi River Basin, KRB, from Nepal to Bangladesh via India, has the diverse communities. People have strong links to ecosystem dynamics and developed knowledge, practices, and institutions to accommodate recurrent disturbances and natural ecosystems. The traditional and local knowledge, TLK, has been one of the key strategies identified globally, but it is poorly integrated in disaster reduction strategies. The project aims to explore ecosystem-based traditional and local knowledge of disaster risk reduction, DRR, in the floodplain riverscape of the Koshi River Basin, KRB, across Nepal, India, and Bangladesh. People's livelihoods are deeply rooted in river-based resources like floodplain cropping and fishing. These are evolved with dynamic interactions and challenges over centuries. The project aims to unveil traditional and local ecological knowledge, TLK, that is relevant to disaster risk reduction, DRR. The major objectives of the project are: identify and document traditional and local ecological knowledge relevant to DRR. Assess mechanisms for applying EBA to DRR. Assess how traditional and local ecological knowledge have been or could be integrated into national policies. Develop a web portal for sharing EBA to DRR. Strengthen the capacity of young researchers professionals. This project is a collaborative research of 7 institutions from 5 countries. It is a 10-member team from Nepal, India, Bangladesh, and Thailand. The project uses a mentor-mentee approach to strengthen the capacity of early career researchers. The project adopted a multi-pronged strategy of collecting data from diverse sources, ranging from online surveys with experts, field observation, focus group discussion, key informant interviews, and ethnological data collection. A total of 380 households were surveyed, including 37 focus group discussions and 52 key informant interviews. Data were transcribed, coded, and maintained depending on its nature. The study showed a wide range of adaptation strategies depending on the type of communities, ecosystems, and hazards involved. Broadly, results from their countries showed that there were site-specific adaptation practices that included: floodplain communities in Nepal are accustomed living in the disaster-prone area by arranging a swift shifting their home when river changes its courses. For this, they developed unique technologies that houses can be disassembled easily by a few people. Carry-on heads with cease and assemble within a few days. Interestingly, people are self-dependent with use of local products for the construction of houses. For example, in Gobagada and Sri Lanka, almost 89% of construction materials are available locally. Local products are abundant, inexpensive, and easy to repair. This is the most common strategy everywhere. Look these photos, local use household poles and what they get. This is an example of Shatoni, where timber is primarily supplied by flooded Koshi from upstream. People have little choice but have accommodate what they get. Now, people are shifted to concert poles that are available in recent years. In such areas, people have low-risk strategy using as little materials as possible in their house. One of the key aspects we recorded in Nepal and India is that people have strong faith and respect to river. Any problems they encountered are not blamed for rivers, but considered as an unfortunate situation they have to endure with karma. Interestingly, there are little or almost no causality. Could be preparedness and skills they have, e.g. swimming or boating. However, faith and belief are critical for strengthening community support and stress management. For example, Nepal and India, people routinely offer worship river and organize fair for respect of river. One participant in Nepal recites the song when there is a flood and/or while crossing dangerous floods. People have unique ecosystem-based strategy that includes use of particular species, ecosystem services. In floodplains, people us indigenous flood-tolerant rice cultivate vegetation that grow fast and climate-type. Resource use strategies suggest the optimum use of resource for livelihoods. For example, people in Gobadaga keep a large number of buffalo for milking, which provide extremely high economic gains. Similarly, floodplain areas are vast repository of agriculture. Large and fertile floodplains in some sections of Koshi River have been lifeline for many people in Nepal, India, and Bangladesh. Such economic opportunities are key in promoting resilience. Local people have best guess when river changes channel. This now impacted dams that control the natural flow of river. People living in floodplains are not happy with dams. In Nepal, the area surrounding Prakashpur benefited from Koshi Dam, but not western section. Almost of all people we interviewed, mostly elder, shared that agriculture productivity is decreased. Their field are not routinely supplied by nutrient-rich fluids. In India, people complained that the incidence of flood has increased as regulated, and slow-paced river deposited silt and raised riverbed. This in turn caused a high frequency of floods. Some parts, water seepage from dam has created the problem waterlogging. People complain that their voices are not heard, with technological and top-to-down approach is working everywhere. Despite government inadequate support, local communities are using new opportunities themselves. In India, people started to cultivate lotus seeds and practice pisciculture. In Nepal, locals are a new resource. Nepal's historical land use patterns have been influenced by a thoughtful understanding of the local environment and the imperative to reduce the vulnerability to natural disasters. In the hilly mountains, settlements were strategically located in elevated areas, often on hillsides, to minimize exposure to floodwaters and other hazards, including landslides and soil erosion. Floodplains, prone to seasonal inundation, were primarily used for agriculture. Such areas are often fertile due to the deposition of nutrient-rich soil and accessibility to irrigation. Seasonal floods during the monsoon, if any, would have minimal impacts on agriculture, causing limited disturbance and providing time for regrowth. Now, roads are built on floodplains that increased the risk disaster. Mountain slopes are carefully maintained using traditional knowledge of soil type, plant physiology, and the extent of risk. These are some of typical examples of this project. Apart from this project, provided a unified repository of TLK to disaster risk reduction, which will host hundreds of cases globally. Project trained more 50 students as research assistants, interns, and collaborators. This project provided unparalleled opportunity on exploring traditional ecological knowledge to disaster risk reduction. The project successfully demonstrated proof of concept. There is need to work on further research and policy integration.